Hello everyone. Today I'm going to be explaining Newton's laws, second law of motion, and basically I'm just going to be explaining it to you, and I hope you guys understand it. My dad is also here recording, so I'm going to be explaining for my mom, but my dad's also recording, so he can learn a bit too. So basically, we're just going to be talking about Newton's laws. So if you just point towards the slideshow, just point towards the slideshow. So we have that sigma F is equal to ma, right? So that's like the universal law that Newton has created. I just covered like different parts of the equation here just to make it easier to understand. So force, an easy way to interpret force is like a push or a pull. So like, I don't know, is there any object here I can use? Like this item right here, I can either push and the force is going that way, or pull and there's also a force coming back this way, right? So force can be either way, and so it's measured in newtons. And then next I just want to talk about mass, which is weighted in kilograms, and obviously it's anything that has like physical matter, or anything that has matter in this universe has mass. So if I were to measure any physical object in this room, it'd probably have a mass. And then the last thing we have is acceleration. And acceleration, like it says here, is how fast an object's velocity changes. So as you'll see soon, we'll be using this example with these two bags, and I'll be showing you, Mummy, how fast how it gets faster. And yeah, that's basically just the acceleration part of it. All right, so now these are the three key ideas that I came up with, and I thought like this is important for you to understand. So more force means more acceleration, right? So if I push with a larger force, like the item will have more acceleration, and you can see that in like many things today, I guess. Like just any item, I guess you like, if I were to put an item over there on like a table, and if I were to like push it, if I push with less force, its acceleration will just be less, right? Because it won't just speed up, it won't speed up as fast. But if I push with more force, then it'll speed up faster. So this is just like a key idea that you should like know. It's for force, it's for all items, right? And then second, we have more mass means less acceleration, right? So think about the equation that I mentioned earlier, sigma F is equal to ma. So more mass is equal to less acceleration. Why? Because just think about it for a second. If you push with more force, all right, actually let's first say that the force is constant, right? And then you have sigma F is equal to ma. The item has more mass. If you divide it throughout, if you use the equation, you can point out Mommy's just like, so she's engaged too. So if you have like sigma F is equal to ma, right? And then you have like the mass, right? Let's say you have like a pencil versus a brick, right? The force is constant. So the acceleration, if you divide by the mass, right, the acceleration will differ, right? So the one with, so that's just how it works with those two examples that I said earlier. And then if the force is zero, acceleration is also zero. So this can mean multiple things. So just think about it, right? So sigma F is equal to ma. If the force is zero, then obviously then the acceleration will be zero, because you divide the mass and then acceleration is zero, right? An example of this would be something that's at constant velocity or just not moving at all. So as you can see, like, I don't know, we can use anything as an example, like this cane right here. Let's say it's standing still. There's clearly no acceleration, there's no force acting on it. So if the force is zero, the acceleration is
zero.
Yeah. Okay. So that's basically it for that. And yeah, also another thing I wanted to mention, I should have mentioned this earlier, but it could also be a constant velocity. So let's say an example of this would be like maybe like terminal velocity. So let's say like you throw something, or no, actually a better example is if you drop something, like off of like a cliff, right? Off the roof. If we go to the roof of this house and drop something, and we drop it, but then eventually the acceleration will fall. And because the acceleration will fall, the acceleration will go to zero, because the object can't physically speed up any faster. Like it'll speed up, but it'll speed up, and then the acceleration will go to 0. Do you know what I mean? So that's basically it for that. But just remember, that's kind of like irrelevant here. Just remember that sigma F is equal to ma. Just remember what I taught you about that. So then an example of this would be the bag, right? I think I mentioned this earlier. These are two separate bags. If I were to push this bag, remember I can push or pull it, but let's say I were to push this bag clearly has more mass. This bag is empty. So if I were to push, and let's say I apply the same force, right? I'm not like forcing anything extra, right? And this one will obviously, you know, just basic knowledge, this one will take more force. I mean, it'll take more work to push like this type of thing, right? It'll take more out of me. But let's say I have this bag and I push with like, let's say I'm just pushing with like 50 newtons of force, right? I'm pushing with this force. What do you notice about the acceleration that the mass, because the mass is greater?
If the mass is greater, the acceleration will be low.
Yeah, exactly. And it makes sense, right? Because
the force is constant in both, but while it's a more mass, the acceleration is low.
Same thing for this. Because it's nearly, I would say, not massless obviously, but it's going near to 0 mass.
Yeah.
Because you have that, the acceleration will be higher. And this can also be noted, like an example is like if your car breaks down, let's say your car breaks down on Ridge Road, you can move the car, right? You can get the car to move. Like the car will start rolling its wheels, and the car has a lot of mass, keep that in mind. But you'll notice that as you're pushing, eventually it'll start moving, right? And like eventually you can keep moving it and then it won't stop like that. You're pushing with a force and the mass of that car is probably enormous, right? So that means the acceleration will be very small, near his leg. Very small acceleration, right? So that's just another example. And then this is the interactive dialogue part, which we kind of just did already, so I might want to skip through. All right, so now we will be doing the assessment. So this is the assessment that I have written out here. So this is the assessment I have written out. As you can see, it says 3 things here. All right, I'll just go one by one. So number 1 is it's a verbal and written test. I'm gonna read it to like the camera first. So question 1 will be if 2 objects experience the same force, which one accelerates more? The object with more mass or the object with less mass?
The object with less mass.
Okay, good. And do you understand why that is? Why the object of less mass that occurs?
Yeah, because the force is constant in both, right? We are not going to make any change on the force, but if the mass is less, then we have more. We can easily do the more acceleration.
Yeah, that's correct. Because in the question states that if 2 objects experience the same force, so Mummy is right. All right, good, very good job. Question 2 is a force of 10 newtons is applied to a 2 kilogram object. What is the acceleration? I mentioned the formula.
It's the equation. So basically, it's 10 newton to 2 kg is around 5.
Yeah. Okay. Yeah. And that's because. Can you explain why? Because F is equal to ma. So explain the math you did.
Yeah, because the mass is 10 newton. The force we applied is the 10 newton, and the mass is only 2 kg, which is very low. So based on that, it's gonna be divided into 5.
Okay. Yeah. Okay. So this is the last question. So the first one was obviously verbal. The second 2. The first 2 were written. Sorry, and the last one will be verbal. So the last one is why do trucks accelerate more slowly than sports cars, even when both engines are powerful?
The reason is that in both motor vehicles, the mass of the truck is much higher than the sports car. That's why.
Yeah, that is correct. And this can be noted with any other thing. It doesn't just have to be these 2, like truck and sports car example. But as you can see, their force will be the same, right? But their engines will be the same.
but the mass is
but
higher.
the mass differs, right? So obviously the truck's mass is way bigger than a sports car's mass, and that again that just goes with anything. So yeah, you're right. That's exactly why. So as you can see here, my mom got all the questions right. Question 1 was B, which she said. Question 2 was 5, which she said, and then she also just said that because trucks have more mass, the same force produces less acceleration, which the same force would in this case just be the different engine. So that's it. Thank you for listening. I hope you had fun listening to what me and my family had to talk about. This is my mom's first time doing physics in like how long?
That was interesting actually, I like it.
But
Especially your example of the car example, that you're putting a force on the car, and then what's between the mass and acceleration.
Okay, and yeah, so when was the last time you did this type of physics work?
Oh,
Like,
I did on my...
like 30 years around, right?
Yeah, on 30
Like,
years.
yeah, so it's been a very long time, so I just started with the basics again, because obviously like Newton's laws are the basics of physics. They're probably the easiest thing that you can do, but if you understand this, you can understand other stuff too. So I felt like approaching the basics first was more necessary, and shout out to my dad. He's been recording the entire time, so and that's it. So
Great job.
Thank you for listening.